Hi, I'm super excited to be here. This talk will be an introduction to Clojure programming language. I love data. I think that the data is the veins in programs, in our programs. And businesses love data. Well, actually, they should be saying that they love information. And 90% of the time, all they want are answers. And it's our job as programmers to provide them with those answers. And for that, we need to create tools, and we use abstractions for that. And sometimes, just sometimes, we over-abstract our programs, and we totally miss the data flow. And it leads to the code like this, enterprise hello world. And I'm not sure about you, but I can't honestly tell what's the data flow from that. And believe me, this code, the only thing this code does, it prints hello world, and it's not even the complete code. It's I reduced it for the purpose of the stock. And imagine that the same code in a multi-threaded environment and running on number of threads. Well, analyzing the data flow in that, it's even harder. And sometimes, if you have to catch the point in time, and when some bug occurred, it's just impossible. And 2 weeks or more running like this dog to find a bug makes you actually rethink your profession, and sometimes just sometimes drop it all together and move up to the mountains. So where's the problem? I think the problem is that we're missing the data flow, and for that again we need proper tools. And well, I struggled a bit, and I found my way in all that madness. And my answer is Clojure. Why? Because it's mostly functional, and it focuses on functions. In corporate, you might argue if Lisp is elegant, but in my opinion, it is elegant, and you can represent the domain pretty well in Lisp. And it has a really nice community that helped me a number of times when I was learning. I'm still learning, but if I were stuck, they helped me a lot, especially using Slack and direct communication, which is just awesome. And it's really mature. Well, it's been 9 years since the initial release of Clojure, and the latest one, the upcoming one, is 1.9, which is still actively developed, and new features come along. And well, the requirements are really low. Because all you need Java Virtual Machine version 1.6, and you can start by incorporating a single jar file into your project, and you're done. So you don't have to convince your DevOps that to install, for example, a new alien virtual machine or anything like that. And you can also use the existing libraries. So if you have a library in Java, which won't be too much functional, but then again you want to use it, you can still use it from Clojure, and it's really easy to do so. So this time I want to tell you a story, and before I do that, I'm going to try to do it in functions. That's going to be the interesting part. But before I do that, I'd like to introduce you and familiarize you with Clojure first, so that we can understand each other. So first, let's start with some simple stuff. Nil, you can think of it like a Java null. Actually, it maps to Java null, and Clojure is compiled language. But most of the features, actually all the features are dynamic, so we can and they are evaluated. On the right hand side, you can find the Clojure REPL. I'm using Emacs REPL, but you can just download the jar and run it to have a REPL. And of course, okay, let's go back to Neil. Well, all the stuff is evaluated, so this example will evaluate to itself. So to nil. And then we have booleans, which also evaluate to themselves. And we have numbers. Of course, they work as expected. They evaluate to itself. But interesting part, you have ratios as well, and of course floatings as you would. There are strings as you would normally enclosed by double quotes, and they evaluate to themselves as well. And the interesting part in Clojure is that you have keywords. You can think of keywords as lightweight identifiers, and they evaluate to themselves as well. So if we write key, it will evaluate to itself. They have a special meaning in maps, which I will be showing in just a sec. But I like to think about keywords like a constant in Java. And there, of course, that's a Lisp language. So at the central point of the language, there are lists. And empty list evaluate to itself again. But anything other than empty list is tried to be is treated as a function. But I would like to show you first the data list. So I'm gonna escape that and using apostrophe. So it's going to prevent the evaluation, and so we can get a simple list just like that. The other collection that is in Clojure are vectors. Vectors are optimized for reading. So between lists and vectors, you can think about like array lists and linked lists in Clojure. Actually, the other way around. Lists are like linked lists, and vectors are like array lists. Okay, so we can have an example vector. And then of course we have maps that hold tuples. So let's have an example like you would take from database, like ID, name, which is an example string, and then just a surname. And I'm using keywords for keys in this map. That's an example map. And now the interesting part, and actually the crucial part of Clojure, all those data structures are immutable. So once you define them, you cannot change them. And I'm going to tell you a secret. Well, I strongly believe that immutability of those data structures lead to cleaner code. Well, if you think about it, you don't have to. At the point in time you define this the data structure, you know that it's never going to be changed. So no more race conditions. You actually have to keep your functions as pure as possible, and I think you're set to go. Now, of course, no language would be useful without symbols. And to define a symbol, we can do it with def. And we can add a name, for example, a symbol, and then provide it a value. And symbols aren't directly evaluated. First, they are referenced. So from now on, we can write a symbol, and we get the value of a. And that's an example symbol. As I said, everything other than an empty list is evaluated, is treated as a function. Well, actually, the first element is the function name. Then goes the arguments to that function. So let's have a plus, for example, and that evaluates to 2, right? The plus is the function name. Then goes the first argument, the second argument, and of course we can define new functions with dfn. Then goes the function name. Let's make greeter function and make it 2 or 0 or more arguments. I'm going to pick 2, and then goes the function body. In this case, I'm going to use the standard function that is called str, which converts everything to single string. And so I'm going to be passing hello. Then the argument that is symbolic, that it was passed here. Then a space, arg2, and the exclamation mark. and we have a function called greeter. So now we can call it as any other function. As I said, there goes the function name in the call. Then goes the arguments. So I'm going to use JDD to get hello JDD Krakow. Okay, and of course we can define functions in other ways, like anonymous functions without the names. Then goes the arguments are inline in this case. And those functions are pure actually, and most of the Clojure functions are pure, but not all of them. For example, there is printline function in Clojure, which produces an obvious side effect. But there it is. So for example, input output weren't purified as in Haskell, but I think it's convenient to do it this way. And now let's begin with the story. And our story begins ages ago, where there lived a king. As you would imagine, the king was called Krakus, and Krakus. Well, first. He was a citizen, so let's define citizen abstraction. And we're going to return a map with key name. And, well, every citizen is healthy, so I'm assuming that that health is constant. And therefore, we can write citizen Krakus. There it goes. And he was a king, so we need some kind of promotion. So we're gonna get a citizen here and a title. And an assoc function is a standard function that returns the map that was passed with an additional key and value. In this case, we're gonna be adding a title to a citizen. All right, so now we can define one more function, king function, and it will get the name, and in it we will promote citizen by this name to be a king. There it goes. So we can write just king Krakus, right? And we get what we expected. Right, but this king had a castle, so we need an abstraction for that as well. And there it is, just like that, a castle abstraction, and the castle was called Wawel. But of course, no empty castle is useful, so we need to define occupy function, in which we're going to use a standard function update that takes a map, and for a keyword, we're gonna call another function. In this case, it's going to be fnil. Fnil execute a function, but if the argument is empty, it will return a default value, because, well, we want initially to have a vector, an empty vector, so that we're gonna use conjoin to add an element to this vector. Okay, so we have occupy function, so we can just write occupy a castle, right, with a king. Okay, and so we have a king in a castle. Now, but this particular king was very rich. In a sense, he had lots of goods, and for that we need another abstraction, so we need food. Food will have just an energy and a size in which someone who eats that will be increased. And so we can define example foods, ram, cow, Okay, so we can just write ram, and we get an example food here. Now those goods were stored in a castle, so we need another function for that. And we're going to again use an update function, this time on the castle. And we're going to do it similar way and add to an empty vector first and the food if it's existing. There it goes. And so we can place an example food in the castle. Alrighty, and then goes the issue, as in live coding always has to be one. Right. Okay. There goes one. Oh, that's a good one. So you didn't fall asleep. Nice. Right, so store. But you can see that the feedback loop is very, very quick. All right, so we have RAM in a castle. But okay, well, not only one RAM, but we just need more, right? So for that one, I'm going to use repeatedly. Which takes an argument, which is the number of times, the size of the collection and a function. In this case, we're going to use cow function, and it's going to create a collection of the size 20, and it's going to 20 times run cow to get 20 cows. There it goes. Okay, of course, the king had bravest knights, so let's define knight. And again, ASOC. And we're going to promote a citizen to be a knight first, right? And additionally, knight will have power of 100. Oopsie. Yes, sure. Alrighty, so I have a knight. Nope. Knight is named, then we have awesome. Knight. Power knight. Yes, there it goes. Okay. Thank you. Still learning. All right, I have a knight Małowój. And of course, he had a lot of them. So for that, we're going to use reduce. So we're going to be reducing the castle. And for each element of the provided map, we're going to the first argument will be the existing castle, and then the next will be the element from the collection, and next we're gonna take that and add another element of the collection, the return, and another element of the collection. So I'm gonna reduce occupy, right, and I'm gonna use map to execute a knight function on each of element of this vector. Okay, that's enough. That's a bit slow. Of course, I'm missing the closing. Okay, and there it goes. I have a number of knights in the castle. But then, at some point, the dragon appeared. And the dragon has a name, and is very powerful. Okay, so I can just write dragon. Of course. Right, and it flew right into Wawel, so we can place them in the castle. Okay, there it goes. And it was ever hungry. So we need to show a way to actually eat something. And for that, I'm going to use merge with. Merge with takes a function and two maps. And if keys of those maps match, it's going to use this function to merge them into one. So in this case, we're gonna be eating the RAM. So it will give the energy from RAM to the dragon. So eat function actually is returning the dragon. So there it goes. But the time came that the king got pissed and ordered to kill the beast. And we're gonna define attack. And again, we're gonna use update. So we're gonna be updating the target. Actually, the target's health. And again, fnil minus this time. So if health wasn't defined, it will be 0. And there it goes. There's the special meaning of keywords. You can actually execute keyword on the map to get the value the value of the map, and if it's missing, the second argument will be the default value. And of course, and so we can attack by the knight, the brave knight, Minigniew. And of course, it wasn't very much successful. And the dragon, of course, struck back. And so we can have a mean to know if someone is alive or not, and we can define dead. That's well, predicates in Clojure have the special notation of a question mark in the end. And we can just compare the health of the person with 0. We're assuming if the health drops below 0, it will be dead. And so we can just write if the attack was successful. And in fact, poor Minigniew died trying to fight the dragon. But in the dark hour, one little had an idea. Actually, the little cobbler had an idea to take a ram, some sulfur and tar, and combined it. To get, again, with merge with, we're gonna combine ram, sulfur, and tar. So we can just have it like that. To create a Trojan ram. And the dragon gladly ate it. And that produced a lot of thirst, and with a great headache. And after drinking a lot of gallons of water. So we are assuming that water reduces thirst, but it increases size. Oopsie. Yeah, I'm missing size. Sorry. And we're assuming that the river, the Vistula River, is an infinite source infinite source of water. So that's a lazy collection in Clojure that is evaluated in the time when we read it, right? So, for example, if we take 100 of Vistula, it's going to be concrete, right? But until it's not, it won't be. So after drinking 100 of gallons of water, the dragon blew in pieces. So we can define piece of. And of course, not only functions could be done in Clojure. You can also create macros on top of other code, as you can treat the code as regular data. In this case, this is a threading macro that is built in Clojure, and actually it's a nice way to write encapsulating elements that work on the same functions that work on the same elements. So in this case, we have a map which we thread over update as a first argument. It's not written here, but it is by the threading macro. And so we're modifying a name with str and adding number after it. And then the result is passed over to ASOC. And so we're assigning health to be negative. And so we can write map. And here is an example of an anonymous function in which we use piece of on the dragon. And that's an argument of this function. So we're going to be passing smog to the first argument, and then each and every element of the collection that will be shown just before as a second argument. So I'm going to use range, which will generate 100 subsequent numbers. And there it goes. The smoke blew to pieces. The cobbler was happy. The king was happy. He tried to give a treasure to the cobbler, but he refused, because he did it for Krakow. And actually, that's the end of my story. But then, well, all of that is was written with pure functions and simple code, and actually, in a sense, it was it was a kind of DSL that I invented for the purpose of this talk, and not many core functions actually were used. And I just wanted to show you how Clojure is expressive. Even a fairy tale could be written in such abstractions. And at the same time, I was in each step I was showing you the result, the data that are beneath those abstractions. So you can easily so you can actually easily at every point it is evaluated, see what are the data. And if you want to play around and see the more concrete example, I have a REST service that is built on that. You don't go away to that abstractions too much. You just call a single function and pass it to get, and you still have what you need, right? And okay, so let's say you want to learn Clojure. How to start? So I would recommend a couple of books that are above. One of them isn't strictly a Clojure book, but it's an introduction to functional programming itself, and there are a number of sites for beginners as well. I especially recommend for Clojure. It's a code golf, and you can step by step learn how to write in this code by passing the tests that are writing a code that will pass some tests that are on the side. And of course, I really recommend to find a mentor, as in each technology. When you start over, if you're stuck, was it a mentor online, for example, on Slack or Twitter or anything else? That really helps a lot when you have problems. And thank you very much for your attention. I will take some questions right now. Here we go. Do we? Well, that's a tough question. I'm not sure how to answer that, but it really depends on what you like and what you want, right? If you really want to go purely functional, then use it, and probability that Haskell gives you, and then go for Haskell, right? But bear in mind that, for example, I'm not sure how mature Frege is. That's the Haskell implementation on JVM. You have to change the stack that you're using. You have to convince people to actually, well, DevOps actually to install something for Haskell, right? And Python is the same actually, right? Anyway, well, I had some experience. Well, I'm married with JVM over 10 years now, so I wouldn't drop that knowledge and go away too far. So I picked Clojure because it runs on JVM, right? But I'm not sure how to compare those languages because they are I'll not say extremely different, but functional programming in them is very different. In my opinion. Any other question? Go ahead. I'm not sure I understand your question. Mm-hmm. The single quote. Well, that's an interesting question because well, as I said, lists are evaluated as functions. So the eval tries to look up the first argument to be a function in a symbol, right? And to prevent that, I use the apostrophe. Then the evaluation, everything that comes after the apostrophe isn't evaluated. Does that answer your question? Thank you. Any other questions? Yeah, that's well. I wouldn't place this in production, but I do have production code both on backend and also frontend. It's not strictly Clojure; it's Clojure script, but it plays well and it's working. Yeah. I have production code. Anyone? Thank you very much for your attention.